Okay, this is chapter 13C. Chapter 13 is about diabetes. We're breaking it into parts because it's a long chapter from the Medical Reformation book. Okay, so we'll just briefly mention a few things we talked about before just to set the stage. Dietary fat, especially saturated fat, will inhibit electron transport on the mitochondria and the intermitochondrial membrane, and that's going to cause things to go backwards. The big guy who figured out a lot of this stuff was Michael Brownlee. The guy's a genius. We talked about that. What a great paper. He wrote the best paper ever on diabetes. Okay, this is just a quick summary of what happens when there is electron leak from the intermitochondrial membrane. Electrons, let's say you inhibit this right here with saturated fat, and then the electron transport starts backing up. Electrons will fall off a coenzyme Q, drop down onto oxygen, become superoxides, and these can cause oxidative stress. Normally, you can neutralize them adequately with superoxide dismutase, but sometimes if it's happening too rapidly, you'll get an excess amount of them, and they'll go to the nucleus and they'll damage DNA, and that'll activate a DNA repair enzyme called PARP. And you need to know PARP because PARP's going to then inhibit the glycolysis enzyme, glyceraldehyde 3-phosphate dehydrogenase. Same thing as 3-PGA-DH, okay? So now we're showing this in glycolysis, and so PARP is going to inhibit this enzyme here, glyceraldehyde 3-phosphate dehydrogenase. So when an enzyme is inhibited, its substrates will accumulate, 3-PGA, 3-phosphoglyceraldehyde. And when substrates accumulate, then they start to run down side reactions, okay? And they can become diacylglyceride, and that will also activate protein kinase C to inhibit the glucose type 4 transporters from going up to the plasma membrane. For our purposes at the moment, though, we especially want to focus on it'll get converted into something called methylglyoxal, usually abbreviated MGO. And MGO will form advanced glycation end products. Okay, MGO can be very damaging. So here's a quick summary of the things MGO can do. MGO can glycate proteins inside the cell and damage them and make them dysfunctional. It can then exit the cell, and it can bind to extracellular matrix proteins like collagen and damage these proteins. So it just goes around randomly damaging proteins. That's not good. Okay, it can go into the blood, and it can combine with albumin and damage the albumin, make that into an advanced glycation end product. It can damage your hemoglobin A1C, and that's one of the things you measure in the blood as an indicator of like hyperglycemia. And there's different types of advanced glycation end products. There are advanced glycation end products due to binding with methylglyoxal. There's advanced glycation end products due to binding with glucose. And there's advanced glycation end products due to binding with AGEs, advanced glycation end products, okay, from fructose. Okay, there's also some dietary advanced glycation end products. So these things all add up. And the body's used to being able to handle them in small quantities. When they become excessive, they just generate more and more inflammation. Okay, but this is a big problem, generating these advanced glycation end products. Okay. They can be taken up by what are called RAGE receptors, and that just means R, receptor for advanced glycation end products. Oh, and they activate pro-inflammatory pathways. I could have gone into that some more. They run this plasma membrane enzyme called NADPH oxidase, and that will just convert more oxygens into superoxide. So you're setting these cascades of vicious feedback to produce more and more problems. They'll also activate nuclear factor kappa B inside the cell. It goes to the nucleus, and it leads to the transcription production of more inflammatory cytokines. These cause platelet aggregation, increased tendency to clot. Here's a closer look at the formation of advanced glycation end products. So here you'll have a protein, whatever it is, hemoglobin, collagen, whatever. And the D-glucose will come and it'll interact with an amino acid on a side chain, like let's say on a lysine as an amino acid within the protein. And it'll bind to it and form an advanced glycation end product. These tend to be irreversible, okay? and this will cause a change in the shape of the protein, and protein function depends on their shape typically, so that'll make it quite often less functional or dysfunctional or completely unfunctional. It can cause real problems. Typically, red blood cells live about 120 days, so the hemoglobin A1C measurement of hemoglobin glycation in the blood is an indicator of overall blood glucose control for the past 3 months. And ideally, you'd like, to have it below 5.5 or less with a normal, healthy person, non-diabetic or pre-diabetic. Okay, here's a little more detail about some of the negative things that happen. Also, when you activate protein kinase C, you're going to inhibit endothelial and nitric oxide, so that's bad. You get vasoconstriction, you get increased platelet aggregation. Both of those things are prothrombotic. Anything prothrombotic means problems for blood flow. You'll increase endothelin, which is kind of like the opposite of nitric oxide. That causes platelet aggregation. Platelet tendency is increased to clot, vasoconstriction, narrowing of the arteries. Again, the opposite of nitric oxide, so that's all bad. You also get decreased ability to dissolve clots, decreased fibrinolysis because you decrease this plasminogen activator inhibitor, okay? You get increased vascular endothelial growth factor, which can cause the formation of new blood vessels in a way that's harmful to health. And those can grow over the retina, cause retinopathy and decrease vision. We talked about increased nuclear factor kappa B being associated with inflammation, inflammatory cytokines. We talked about NADPH oxidase, increasing reactive stress. It's all bad. Basically, everything bad happens. Okay, that's why Nathan Pritikin, he said fat is bad, and that's why I'm a big believer in low-fat diets, and I think all this good fat stuff is a bunch of nonsense. Okay, they also have done studies on feeding people very low amounts of fat, and the people do very well. Okay. Oh, also the fact that you're blocking nitric oxide, you're going to cause vasoconstriction. That's going to raise the blood pressure. When you have to pump blood through a constricted system, pressure has to go up to do that. Okay, here's a Banting lecture, and this is the lecture of Gerald Shulman. And this guy's a genius. He was over at Yale. Like I said, he did some work with Roy Taylor. In 2018, he won the Banting Award as best diabetes researcher in the world. And they confirmed that the earliest detectable finding with insulin resistance is accumulation of fat inside skeletal muscles. And they call that IMCL for intramyocellular. So intra being inside, myo muscle, cellular, the cell. Lipid. Lipid is just another word for fat. So this all reinforces the idea that the best thing to feed diabetics is a low-fat diet. Okay, and Shulman promotes what he calls the ectopic fat theory, that normally fat should be stored in fat cells like your subcutaneous fat cells, and it really shouldn't be accumulating in the liver. When the liver becomes fatty, it loses its ability to correctly monitor blood glucose level, and it keeps on sending more glucose into the blood than it should, let's say through gluconeogenesis or the breakdown of glycogen. So you'll get hyperglycemia, high blood glucose levels, even when you're fasting. Okay, so that's bad. The continuously chronically elevated blood glucose level are toxic to other tissues because we've talked about skeletal muscle cells being able to regulate the amount of glucose that they take up because they've got those glucose type 4 transporters that are sent to the plasma membrane when they want more glucose after insulin is bound. But there's other cells that are called constitutive, and what that means is they always take up glucose in proportion to the blood level. So these cells are vulnerable in the setting of chronic around-the-clock hyperglycemia to taking up too much blood glucose. So they can't protect themselves from chronic high blood glucose level, chronic hyperglycemia. And this includes endothelial cells, so they get damaged and they cause what's called a microvasculopathy, and they especially will occlude the little arteries in the foot, and that's why diabetics get tons of amputations. Every day I see diabetics getting their foot amputated. It's super common. Okay, retinopathy is a common cause of people going blind because we talked about that increased VEGF, vascular endothelial growth factor, leading to increased growth of abnormal blood vessels over the retina, causing blindness. They get damage to kidney cells too for the same reason because you can get an overnutrition effect when there's too much glucose coming into the cell. You don't get that in skeletal muscle because it can control how much comes in. But when you can't control it, like in these cells, endothelial cells, meaning arterial lining cells, you get a vasculopathy. In the eye, the retina, retinopathy. In the kidney, nephropathy. And in the nerves, you get a diabetic neuropathy. So for all these things, a good thing to do is eat a low-fat diet. Okay, here's a guy who won the Banting Award in 2012. This is Roy Taylor, and he did a lot of research showing the effect of weight loss and preventing fatty liver on improving control of diabetes. And this is a quote from Roy Taylor. He says, "Type 2 diabetes is really a condition of fat excess, to which some people are more susceptible than others. People have different, what he calls a fat threshold. And that just means that some people get diabetes at a lower amount of fat intake and a lower amount of fat storage on the body than others do." And he was able to quantify the amount of fat in the liver. And what he showed was as the liver fat started going up, they started getting more and more insulin resistance. And typically he found if they've had diabetes less than 4 years and he could get them to lose 30 or more pounds of weight, it would just go away in almost all of them. So that's wonderful news. He's able to just cure them. Whereas you go to conventional medicine, they never cure a patient. They have a 0% cure rate. Whereas this guy's saying almost all of his type 2 diabetics who had it less than 4 years, suggesting they still had intact ability to produce insulin in the pancreas, they all got better. And then he would recheck to confirm that, yeah, they had been able to clear the fat out of the liver. It tends to come out of the liver first because the liver is so metabolically active. And what's the secret of losing weight? You know, eat a low-fat, low-sodium, whole food, 100% vegan, starch-based diet with no oils, no caffeine, no sweets, no alcohol. That makes you lose weight. Like I said, look at China before 1970 when they ate white rice, 90% of their calories, 1 billion out of 1 billion are skinny. That's how you can figure out what diet works, is just look at the epidemiology. It's also good to filter your water to get the estrogenic chemicals out of there because those are fat storage hormones. Okay, this was a little more from Roy Taylor's work. So basically, once fasting glucose will come down to normal once the patient's lost 30 pounds or more, because these are all fat people. So that's nice. There's a doable thing you can do without needing a big surgery, without needing to take any pills then or injections the rest of your life. And here's a book he wrote about it, Life Without Diabetes by Roy Taylor. He's got lectures. You just go to go on to YouTube. You could watch his lectures pretty easily. The other guy's lectures on YouTube too, Gerald Shulman. It's really good. So I'm making that point. The main cause of insulin resistance by far is excessive intake of dietary fat, especially saturated fat. But there's other things that contribute to insulin resistance. And I made a YouTube video and a newsletter about other causes of insulin resistance. And I'm going to make this a separate video. Okay, so we just completed 13C on diabetes, and we'll do the other one in just a little bit.